Hello and welcome to another coding session with Rune. This video is about dispatching async functions in dynamic dispatch. So I just made a video about static versus dynamic dispatch. In that video, I just explained the very basics of how to use it. But one of the things, if you work on async applications, one of the things you might run into very fast is that you cannot actually use async functions in traits which are dynamically dispatched. Now, your first instinct might be to grab the async trait create, which does solve it, right? But I want to go into the details first of why it can't be done and how we can solve it and what the async trait create does and why you probably don't want to use it. Okay, so very simple setup here. We got an app. It has a greeter, which is dynamically dispatched, right? It's a dynamic reference. And when we start the app, we're obviously going to greet the user. And I want to do this async. So pub async fn greet, and well, it's async, so we can await it, right? The problem is the compiler will very quickly complain that it is not dyn compatible. And if you actually, when you get that error, sorry, you can hover over the trait and see why. So it says here, it's great, it's not dispatchable due to being async. It's a nothing burger, right? It doesn't really explain why. So if you know anything about async functions and how they work, an async function is just something to tell the compiler that it needs to generate a state machine that is awaitable in some sense. So what this gets desugared into is actually a function greet that returns this state machine. Now, the state machine itself has a unique type, right? Because the state machine is unique to this specific function, which is actually where the crux of the issue lies. So this is what it gets desugared into. If we now save, we get a different error message. It is not dyn compatible due to having a method that's not dispatchable due to the return type referencing self. Do you see self here? I don't. Well, that's because you need to consider what this means. When greet is created, when greet is desugared from being async, actually this returns the type, right, of the state machine. And but where does the type come from? Well, it's put on the trait. So what actually happens is that we have a type t here, which implements this future. And then this references that type. This is how it works. Okay? So again, this type corresponds to the type of the state machine. And obviously you can await that state machine. Problem here is this is not friendly, right? Because if you want to use it, you need to know the t, right? In the same way that we did this here. You need to know the t. And obviously we don't know the type of the state machine, but the point is more so that if you want to dispatch a function using dynamic dispatch, you need to know the exact signature. You need to know the exact signature. And the signature of this is different for every implementer of async greeter. So this is not going to work, and this is why async functions do not work in async or like in traits if you're dynamically dispatching, right? If you're not dynamically dispatching, then the compiler can actually like figure out like, okay, well, they're clearly returning this, so I can continue with that. So what do? You return a box future, because a box future is known, the type is known and always the same, right? You just say like, okay, well, I give you a box with a future inside. And that's fine. That's completely fine. This is dynamically dispatchable. There's one more thing. It needs to be pinned. Because if it's not pinned, then it's not a valid future. And you know this if you know anything about futures. So this is actually how you solve the async function in a trait issue. Now, how do we actually create an implementer? Let's just do that. So again, we'll create a polite greeter. And then we're going to implement this async greeter for the polite greeter. And the way I like to do this is you have like an inner function, or you don't need to. You don't need to, but you can. So what you do is how to create a pin box is by calling box pin, right? And then you can say box pin async. Right, just going to create an inline async function. What I was about to do is just create like a greet inner. You can do this, right? And then just make a greet inner function on this, or you can do it inline, which is sometimes a lot more ergonomic, or like at least doesn't clutter like with functions outside of the implementation, but only made for the implementation, if you know what I mean. In this here, you can do just println name, good day to you, name. Now I hope you can tell me why this won't work. It borrows name, async move, and you're done. And you're done. How do you create? So how would you create? Okay, let's first just run it. Let's first just run it and see, right? So with the app greeter, we're gonna make a box new polite greeter, right? And then app start dot await. Okay, let's run, and then we can see it actually properly dispatched the async function, and we can actually Tokyo sleep probably. Okay. Did we not add sleeping? Time? I just want sleep, man. Yes, there we go. Duration from milliseconds. Let's wait a second. Let's wait a second. There we go. Okay, so the async actually properly works. And what did I want to do? I wanted to show you how to do reference data. So if this happens, then it clearly doesn't work, right? Because this gets put on the heap, and it assumes a static lifetime, which is not valid because name is not a static thing. So we're going to name it, right? We're going to say like, okay, we're going to give this, let's just try this, right? We're going to try this, and then we're going to say, well, actually, the thing that's boxed is for at most n. It's incompatible with the function signature, which is true. So do this, and then we do this, and it works, right? We can see that it actually does work. Now we're going to talk about async trait create. Cargo at async trait. Okay, so if you do this, async greet, this is what people often recommend, right? What's wrong? Oh, FN. This is what people often recommend, that you just do this. Let's just make an implementer. Good day to you. Just do the exact same thing. Okay. Like this. Kill all that. Right, people say like, hey, if you encounter this issue, just use async trait. How does that work? Well, you use this proc macro, and you put it above the impl and the trait, and then it magically works. Oh, I didn't add a delay, did I? Let's add the delay. Let's await it. Bloop. 1 second, and there we go. So this may seem a lot more ergonomic, right? But we can actually see what it is doing if we do car expand. So what does async trait do? It adds 3 lifetimes it adds a self lifetime, it adds a name lifetime, and a lifetime of like, I'm not even sure what this is. The point being, it adds 3 lifetimes that you just don't need. And I've worked on a code base where async trait usage was very common, but it actually slowed the compile time down by like 2 full minutes out of the 3 minutes, right? So removing async trait actually improved the compilation time by 60%, which was kind of crazy. Like, please consider not using this crate. It will slow your compile times down a lot if you're not using it correctly, right? So just be aware, this is what it does. You can just do this yourself, but without all the lifetimes. Okay, and you don't have to confuse the constraint checker. Okay, and I think that will be it for this video. So this is how you do async in a static dispatch scenario. Have a nice day.